The Brainiac Hall of Fame is a fitting tribute to some of the men who have pushed forward the boundaries of science. Men like Einstein, Sir Isaac Newton, Derek Acorah, and of course, John Tickle. But today, we're here to solve a problem between two of the brightest stars of science, Galileo and Aristotle. They couldn't agree on one of history's most burning questions. Do heavy objects fall quicker than light objects? This is a pillow, and this is a cooker. Both household objects, but both used for very different purposes, as I know from bitter experience. The cooker weighs 400 times more than the pillow. John, what do you think's going to happen?
Well, Aristotle will say that the cooker is going to fall 400 times as fast as the pillow, whereas Galileo will maintain that they'll hit the ground at the same time. I'm with Galileo. The mass of the object has absolutely nothing to do with the speed with which it will fall.
I think the cooker's going to land first, and the pillow will float down gently. Let's find out. Come on, let's go and find out.
This is science. They're going to fall exactly the same way.
Myth has it that in Renaissance Italy, Galileo proved that light and heavy objects fall at the same speed by dropping two cannonballs of different weights from the Leaning Tower of Pisa. Meanwhile, in ancient Greece, Aristotle thought light and heavy objects fall at very different speeds. But being a typical philosopher, he never bothered testing anything in the real world. So it falls to us to winch a cooker and a pillow up to a height of 60 metres and finally answer the question. It's like they're there.
We'll see who's right now, Vic.
I think you'll find that it's me. That
Yep.
goggle's on.
Right, yeah.
Let it drop!
Oh, there they go, there they go!
And the pillow still floats!
Oh, that's taking ages.
I think I won that round there. The cooker goes off like a hare, whilst the tortoise-like pillow follows leisurely in its wake. Oh! Oh! Only a fool would say that Aristotle wasn't completely right.
Aristotle wasn't completely right, was he? Because if he was right, this would have fallen 400 times as fast as the pillow. Now, clearly that wasn't the case.
Which landed first, John?
OK, Vic, the cooker landed first.
Thank you. So much for the cooker and the pillow. But let's give Galileo the benefit of the doubt and drop two balls of differing weights from 56 metres, the same height as the Leaning Tower of Pisa. Well, it's 1-0 to Aristotle, but now we're on Galileo's home ground with two balls of dramatically different weights. We've got a cannonball and the football. What's going to happen, John?
Well, Vic, I've been having a think, and I reckon the lack of aerodynamic properties of the pillow combined with its relatively low mass meant it was more susceptible to air resistance. Now, as you pointed out, vastly different masses on these balls, but the same aerodynamic shape, so air resistance shouldn't be a factor.
So which one's going to hit the ground first?
It's going to fall at the same rate and hit the ground at the same time.
I think you'll find it's the cannonball.
No,
Let's find out.
I'm going to prove you wrong.
For the first time in 400 years, two balls of different weight dropped from the height of the world's most famous Wonky Bell Tower.
I have absolute faith in our friend Galileo.
What, an iron cannonball?
Yeah, and a brass cannonball.
But that's a football filled with air.
It doesn't matter, they're the same shape, so they're going to hit the ground at exactly the same time, I reckon.
Let it drop!
Well, all right.
So, another result that only a man who's taken complete leave of his senses wouldn't describe as a total victory for Aristotle. Which landed first?
Well, technically the cannonball. Got a theory.
Technically, it did.
I've got a theory about it, though.
Yeah?
Light objects, like the football, will only accelerate for a certain amount of time until air resistance counteracts the acceleration due to gravity, and it'll reach its steady speed, known as the terminal velocity. With a heavy object, like the cannonball, air resistance isn't such a factor. It won't reach its terminal velocity.
So what do we do about that?
We'd like to have the experiment in an airless vacuum, and then air resistance wouldn't be a factor.
Well, we couldn't arrange for an airless vacuum in our car park. Instead, we've got a heavy lorry wheel and an even heavier Daewoo Nexia. Two objects unavailable to either Galileo or Aristotle. The object's heaviness will, according to John, counteract air resistance over the 60-metre drop, and we should finally know which of the old boffins was right. Ready? 3, 2, 1, let it drop!
Oh, come on! space, Aristotle!
Take air resistance out of the equation and you get neck and neck free fall of both objects. You can clearly see the wheel and the much heavier car falling at the same rate. Just as Galileo predicted.